to do this just like an old school division problem. You set it up like this, where you're dividing x to the n minus 2 into the other polynomial. And what you do is you look for a number to put up here at the very beginning that multiplies together with x to the n, and results is in x to the 3n. And the number that does that is x to the 2n. Remember that when you have the same base, you add the exponents. So x to the 2n times x to the n will give you x to the 3n. So you multiply that out and give you x to the 3n. And then you multiply the x to the n times the minus 2. That would give you minus 2 x to the 2n. Now, this is a little tricky here because in an old school division problem, you subtract. So we have to do that. Subtract, subtract, which means we change the sign. And we add the numbers together. We're gonna get minus x to the 2n. And then we bring down the 5x to the n. And then we ask ourselves, what number do we need to put up here next to the x to the 2n that multiplies to x and multiplies with x to the n and gives minus x to the 2n. That number will be minus x to the n. Remember that we add exponents again when we multiply the numbers. The negative gives you the negative sign. X to the n times x to the n is x to the 2n. So we get minus x to the 2n. And then we're going to multiply minus x to the 2n, or sorry, minus x to the n by minus 2. And we're going to get plus 2x to the n. And then we have to do the little trick again where we change the signs and add. So subtract, subtract. This will get 0. This will get 3x to the n. And then we do the same thing. We figure out what do we need to put up here to multiply by x to the n to give me this. I forgot to break down the 6. And the answer to that is 3 plus 3. When I multiply that times x to the n, I get 3x to the n. When I multiply 3 times negative 2, I get negative 6. Change the sign, add, and you get a 0 remainder. So the answer is x to the 2n minus x to the n plus 3.